let's do one more example using all the rules of implication that we've learned so far. Right, so once again we have this new example, and again we're trying to get D or B as our conclusion. We're trying to derive that. Now in your book, one of the strategies says that if your conclusion is a disjunction, then what's going to happen is either at some point at the very end you're going to have to add, or you're going to have to use constructive dilemma here. So let's go ahead and start working our way through and see where we can go with this. This one's a little more complicated than usual. Now what we can see here is that we have two lines that are conjunctions and one line that is a disjunction. Now this looks, and within each of these conjunctions we have conditional statements. This looks an awful lot like CD over here, so that should give us a tip-off here. So let's see whether or not we have constructive dilemma at play here. And in fact we do. So we see here on lines 2 and 3, okay, so the disjuncts on line 3 are a match up with the antecedents on line 2 here, right? So indeed we can use this rule of constructive dilemma. So we use lines 2 and 3 using CD, constructive dilemma, and we can therefore derive then the consequence of each of these. So we can get D or C, okay? All right, so we've sort of used these rules here. Now we have, again, another disjunction, and we still have this conjunction of two conditionals, so we can once again see if we can use CD here. And in fact we can, okay, it's the disjuncts are matching up with the antecedents here on line 1. So using lines 1 and 4 and the rule of CD, we can thereby derive B or D, okay? All right. Now, this is sort of the tricky part on this proof here. So this is only getting us so far, and again we want to get D or B, but we want to figure out, we need some way of deriving that as a disjunction. And so this is sort of backwards. So the point here is that because it doesn't seem at this point that we can use addition, then probably the rule that we're going to have to end up using to get this is going to be constructive dilemma. So is there a way that, given line 5 that we have, we can make a constructive dilemma? Well, actually we can, okay, because again, what we're trying to look for here is we're trying to create a conjunction of two conditionals that have these two letters as their antecedents. So it kind of, this is kind of tricky. You kind of have to think a little backwards here on this. So if we go back to lines 1 and 2, our original premises, we can see here that, hey, we have, if we, again, we're trying to eliminate the antecedent and derive the consequent here, we can see that, oh, look, we got B horseshoe D, and we have B or D. Well, if we, somehow had constructive dilemma, we could eliminate the B and get the D, and that would be on the right side here for the conclusion. So let's go ahead and derive from line 2 B horseshoe D. And how did we derive this? Well, because the main connective, the operator here, was an ampersand, we can use the rule of simplification. So on line 2, if we simplify out, we can get B horseshoe D. Right? But we're not there yet. Okay. So yeah, we got this. We got one side of our conjunction that we want, but we want to find a conditional that has D as the antecedent. Well, where do we see that? Well, we see one here on line 1. So once again, we can do, because the main connective here is an ampersand, we can do simplification. Okay? So we can derive out D horseshoe B. Okay? Alright, so again, we're trying to create a constructive dilemma because we've already eliminated the idea that we're going to do something with addition here. So in order to get that, we're going to need to conjoin lines 6 and 7. So we got B horseshoe D and D horseshoe B. And we got that again by lines 6 and 7 through the rule of conjunction, combining two lines there. And so finally now, we can take line 8 and line 6 here And using the rule, or excuse me, line 8 and line 5 here, excuse me, we can use the rule of CD and derive out D or B. Right. And there's the proof for this particular problem. Again, this is maybe not necessarily a rule that I think they mention in the book, but if you end up, as a kind of general practice, if I see a proposition that has its main operator as an ampersand, as a conjunction, I just automatically simplify. If you have extra steps in your proof, that's not something that I would count points off on. Okay, if it ends up like you simplify out, like say in this case you simplified out C horseshoe D and E horseshoe C, and you never used it, that's fine. It's just a kind of, this just is like the sort of the quickest way to prove the conclusion here. So again, the trick with all of this, as always, to repeat and over and over again, is just being able to see the forms, these rules of implication, within the proofs themselves. And that will be the trick to determining whether or not, and how an argument is valid. Okay. But I think, natural deduction can take a little work, but I think it's an ultimately much more elegant way of proving validity than, say, the truth table method. And it actually gets you to the point where you know why arguments are valid, because the forms are within that particular argument.